Since we finished talking about the association rules in terms of the support and confidence, it is time for us to take a look of more advanced topics. So I prepared 2 advanced topics to discuss with you. The first one is the misleading rules. Sometimes the rules that you found that pass the minimum support and minimum confidence, indicating they are strong association rules, sometimes they don't really mean what you think it is. And that's something we want to discuss over here. After that, we want to look into the multi-level association rules. Sometimes your item sets have some hierarchies over there. So how would you adapt those hierarchy concepts into your association rules? So those are the 2 advanced topics we want to discuss about. Starting with the first one, misleading rules. Let's take a look at an example. And this example will tell you why sometimes the rules are really misleading. So saying that we have 10,000 transactions, and as a manager, we want to find some information out of it. So we looked into all the transactions that we have, and we found out that there are 6,000 of the customers that purchase computer games. So among all 10,000 transactions, 6,000 of them purchase games, which means that 60% of our customers who are purchasing the video games. And then there's about 7,500 buying the videos. So that's another 75% of our customers that buys the videos. And we try to look into the rules, finding out that the customer who purchased both of them, that includes 4,000 of those students. That means there's about 40% of the customers that purchase both of them. And therefore, based on these information, we try to find the probability that buys both of them are 40%. And of course, with all of this information now, we can calculate our rules, our association rules, to see that if customer buy the video games also buy videos, or the customers who buy video also buy video games. And so when we try to do this calculation, let's take a look at this. The support among all 10,000 transactions, 4,000 of those that purchase both of them. So the support is 40%, which is pretty high. That sounds good. Now, if we go from the game to the video direction, so the number of games purchased with 6,000 transactions, which is about 60%, and the number of the items they purchased together about 40%. So this shows that looks like a good confidence. And therefore, suppose that our minimum support is 30%, which passes. Minimum confidence 60%, that also pass. So we may come to a conclusion saying that people who buy game will also buy video based on our association rules definition. There's nothing wrong at this stage by giving that rules to the manager. And then manager sees that rules saying that it is not the case. Why is that? We use our association rules and finding the information that we are interested in, and now the manager say, no, he didn't do a good job because something is weird here. They are what they call a negatively associated. Wait a minute. So at this moment you are thinking, based on my association rule, I'm saying that people who buy the game will also buy video, and that is tested by our strong association rules. So it should be the case. Why the manager saying instead of buying the games who goes to video, is saying that people who buy game is actually less likely to buy the video? That is totally contradict to the rules that we found. So what is going on? And the manager keeps saying that means the purchase of one of these items actually decreases the likelihood of purchasing the other. So you have a lot of questions, and then saying that how does that conclusion been drawn. So this is something very interesting, and that's something I want to discuss with you guys. So think about this. While 60% buying the game and 75% buying the video, those two percentages are actually very high. Therefore, think about this. If you have a value of 60%, multiply 75%. That's giving you, if that is the case, then you should naturally have 45% of customer buy both of them. But in fact, there's only 40% that purchase that way. And therefore, you would understand it's actually less than that 45%, indicating they are less likely to purchase two items together. And this is the additional layer of the check to see about your strong association rules. This is what we call a lift. A lift is the occurrence of product item A is independent of the occurrence of the item set B if the probability of A item multiply the probability of the B item will equals to the probability that both of them are purchased together. So if that was 45%, that means that is pretty equal to each other. So there's no affiliations which one is more likely to do what. But in the case, in the examples, the 40% is actually lower than 45%, that indicating they are negatively associated. On the other side, if there is higher than 45%, that's indicating they are positively associated, which makes our strong association rules even stronger. And that's something we want to look in here. Therefore, if they are not equal to each other, they are dependent and correlated events. So the lift A and B equals to P, A union B divided by PA multiplied PB, and that is how we will be able to calculate the lift and adding an extra layers on top of our association rules. So if the value is less than 1, the occurrence of A is negatively correlated with the occurrence of B. On the other side, if that's greater than 1, then A and B are positively correlated. So that's something we want to see. And in our example, you can see that it's actually 0.4, which is 40% divided by 0.6 multiplied by 0.75, which is 0.45, which is less than 1. And that's how we will be able to see by this example, they are negatively associated. Of course, at this stage, you will be very interested in what happens if we apply lift onto the association rules or the strong association rules we found in our 9 transaction example. Of course, let's take a look at this. So this slide shows that based on the frequent item set, so when we were calculating the support, we used this figure. We're finding out several items, candidate, generating 2 item set, generating 3 item set. So this is the figure that generates our frequent rules, which the rules pass minimum support. And after that, we looked into the confidence table, confidence check, and therefore these are the slides that checking one by one. You see that we have 6 2-item sets, and that's why we check one by one, finding out the rules that pass the minimum confidence, and that's how the red rules are the one that consider as strong association rules. And not only that, we also go into the 3-item set. We have one 3-item set, including here we have another one included in the confidence testing, and unfortunately none of them pass. That's why we only list out these 3 slides, previous slides over here, indicating these are the rules. We have 3 rules that are 3-item set. We have 7 rules that are 2-item set. And of course, to double check on those things, we want to see one by one what is their lift. So by doing the calculations, this is also something I discussed in the previous video, indicating that when we were calculating the frequent rules, we actually have every single item's frequency already. So keep all of this information, because not only you can use that in confidence calculation, you can also use that in the lift calculation. So when we were doing that, to make sure you understand what's happening, I keep those slice occurrences over here. So try to think about this. If we have rules that indicating item 1, people who buy item 1 will also buy item 2, we then need to calculate their lift to make sure are they really positively correlated or they are actually negatively correlated. To do that, we need to find out the probability of 1 and 2 being purchased together divided by probability of 1 multiplied probability of 2. And that's why we will get this value. Probability of 1 and 2 occurs together, we can easily check here is 4 times that occurs together. So 4 divided by 9, that's the probability of 1 and 2 being purchased together, divided by PA, which is probability of item 1. We know item 1 6 out of 9 times, item 2 7 out of 9 times, and therefore we will be able to get a value. And it's actually a negative value. It's not too bad, but it's actually not that correlated. On the other side, 1, 2, 3 is going to do the same thing, probability of 1 and 3 being purchased together, which is 4 out of 9 times over here, divided by P1, which is 6 out of 9 times, multiply P3, 6 out of 9 times. And that's why we can get a very normally distributed, which will give you a lift of equals to 1. So it's like a not really positively or negatively correlated rules. We then can look into the 3 item set. C5, remember that item 5 occurs only 2 times, but every time it's been purchased, it has been purchasing the item of 1 and 2. So to do that, we can see the probability of 1, 2, and 5 being purchased together, which is 2 out of 9 times, divided by P5, number of 5 that been purchased 2 out of 9 times. Probability of 1 and 2 is 4 out of 9 times, and that's why we actually get a very highly correlated rules over here. We will be able to do the same thing on C2, 5 to 1. In this case, because C2 and 5 is actually the same value divided by C2 and 5 as 2 out of 9 times, and 1 is actually 6 out of 9 times, and that's actually diluted the value a little bit, and then you get a lift of 1.5, still a positively correlated rules. To give you a full complete picture of what's happening, this is something that I generate for you guys to for you to understand. For all the rules that we get, including 7 2-item set, another 3 3-item set rules, we actually calculate all of their lift, finding out that there are 3 rules that has a correlation greater than 1.5, and I have marked those values out. So those can be some rules that are very, very interested for the checking. So it gives you additional advanced topics. Not only the support confidence lift can also help you to identify some rules that are even more interesting. Finally, multi-level association rules. In the idea of the multi-level, sometimes when we look into all our item sets that we are doing this sales, you can see that we can have like computer. Computer can be further divided into laptop and desktop, and they can be divided in by different brands. Same thing about the software, printer and camera, computer accessories. So you can see that we have hierarchies among all the products that we have. If we look into the Kroger, we can have vegetables, and we can have fruits as the major categories, and we can have meat, and then we can have so many different things, and all of them can form the hierarchies. The idea is this: while we are trying to calculating the association rules for the support and confidence, based on what we discussed, we set up like one value. Minimum support equal to 20%, minimum confidence equal to 60%. That can do well in most of the situations. However, if we comes to the idea of hierarchies applicable over here, then we may want to decide or define some parameters to go with the hierarchies over here. So for example, you can see that we can create some flexible support settings. Items at the lower level are expected to have lower support. And on the other side, items at a higher level should have a little bit higher support. So in this case, we can define some parameters over there to reduce or increase the supports that we want to set it up. And therefore, you can see that for the milk level, we can say support equals to 10%. When it comes to 2% milk or skim milk, we can have some way of generating some parameters or some user-defined marked variable supports to help us identify different rules over there. And that is something, and also one thing you can see is that it is also possible that you can build up the bottom layers supports and sums them up to create a higher level of the support. So this can go all the way into as research topics. So I don't want to go too deep over here, but I just want to point it out to let you guys know that that is like one areas that can be studied, and of course different application concepts and different application topics can have different settings over here. So some rules may be redundant due to ancestor relationship between the items. For example, milk to wheat bread, say that we can have a support of 8%, confidence of 70%, while we get another rule is saying that 2% milk goes to wheat bread. This supports 2% confidence as the 72%. So that obviously these two rules has some relations over there, because 2% milk is part of the milk. Both rules as passing the minimum support and minimum confidence. Say that our minimum support is 2%, confidence is 70%. So in this case, which rules that are more meaningful to you can also depending on the applications. So more importantly, this example wants to point you out that the first rule, which is this rule, is an ancestor of the second rule. So it has a higher level of hierarchies in terms of the levels over here.